Professor R. Ashokamani, Director, Research and Development, Dhanalakshmi College of Engineering, Tambaram, Chennai. He is former professor and head of the department, Physics, Anna University, Chennai. He is presently guiding 3 research scholars. He has more than 44 years of UG and PG teaching experience and 33 years of research experience. 14 research scholars have obtained doctorate under his guidance in the area of material science and solid-state physics. He has more than 150 research publications to his credit, of which 90 are in international journals. He has authored a book on solid-state physics, which is an international publication. He has participated in several international conferences, both in India as well as in foreign countries such as USA, UK, France, Germany, Italy, and Yugoslavia. He has been a guest scientist at ICTP, Italy, several times. He is a fellow and treasurer of Tamil Nadu Academy of Sciences.
Welcome to the UGC lecture series meant for the BSc Physical Sciences students who are having the paper on applied electronics. We have been discussing a few things regarding nuclear physics, and now in basic physics 2 we have in the unit 4 the section on radioactivity. The contents of this lecture will be as follows: discovery of radioactivity, 3 kinds of emissions, examples, gamma radiation. As far as the contents are concerned, you find that discovery of natural radioactivity. This obviously makes you to think whether there will be, if there is natural, will there be artificial radioactivity. Let us now pass on to the discovery of natural radioactivity. It was an accidental discovery which was made by the French physicist Henri Becquerel in 1896. You should all remember in the year 1895 when Röntgen discovered X-rays. So, people thought there might be some materials which will emit radioactivity, which will emit X-rays if they are exposed to sunlight. Hence, Becquerel exposed the following material, potassium uranic sulphate, to sunlight and then placed it on a photographic plate wrapped in black paper, believing that uranium absorbed sun's energy and then emitted X-rays. Therefore, Becquerel expected X-rays to come from this material, namely potassium uranium sulphate, when sunlight is falling on the material. That is what he expected, and it so happened in Paris on 26th or 27th of February, when the experiment was done. The sky was cloudy, there was no sun. In spite of the fact there is no sun, or there is no radiation from the sun, still the plate got exposed. The photographic plate had very intense marks indicating that some radiation is coming from potassium uranic sulphate even when there is no sunlight. And it was believed that they are X-rays, but of course, one has to examine whether the radiation is really X-rays, or what is the nature of radiation. Becquerel was surprised to find later that uranium had caused the plate to be fogged up as if it had been exposed to light. He correctly assumed that uranium was emitting radiation similar to visible light. So, what you understand is, from potassium uranium sulfate some radiation was coming, but the important thing to be noted, when the radiation is subjected to magnetic field or electric field, it was found that the radiation contained positive, negative and neutral radiations. They form part of the electromagnetic spectrum. Light cannot be deflected by electric field or magnetic field. X-rays cannot be deflected, because X-rays are made up of photons which are chargeless. They cannot be deflected by electric field or magnetic field. But here is a case, the radiation coming from potassium uranium sulfate is getting deflected, and the radiation consists of three kinds of emissions. One is positive, the other is negative, the third one is neutral radiation, which goes undeflected. Now, these studies were made by Becquerel himself, mostly by subjecting radiation to an electric field, applied electric field. He was able to show that a magnetic field seemed to change the direction that of this invisible radiation. The nature of radioactivity and its origin and the understanding that we have got, the credit goes to people like Sommerfeld, the Curies, I mean Madame Curie and her husband Pierre Curie, Villard, Soddy and many others. So, they found the radiation coming is not X-rays, that is a very important one. Some activity, something is happening, some radiation is coming, and of course, one does not know where from does it come. Now, you should all know that X-rays are due to collision between photons and electrons, right, collision between photons and electrons and atoms. But these radiations which are coming, where from do they come? So, this is the photographic plate which got fogged up, and you got a uranium salt wrapped by means of black paper. Even though there is no sunlight, the radiation is coming out, and the radiation subjected to a magnetic field or electric field shows the kind of the positive, negative and so on. I will show the setup which was used by Becquerel himself. Henry Becquerel himself, he showed this kind of when the radiation is coming, it is subjected to a electric field, and he found that something going towards the negative plate, something going to a negative plate means that radiation should be positive, right. That is the reason why it is attracted by the negative plate. On the other hand, something is going towards the positive plate, that means it should be made up of negative charges. The other one goes undeflected, note the center, right, radiation that is going towards the in the center, that goes undeflected, that means it is neither positively charged nor negatively charged. So, you find one kind of radiation going in this direction, which should obviously consist of positive particles. This should be made up of negative particles, because they are attracted by the positively charged plate, and this goes undeflected. That means there should be some radiation, something like X-rays, right. X-rays are not deflected by electric field or magnetic field. Therefore, electric field down the page between the charged plates, it clearly shows that the radiation coming from the uranium sulfate is made up of three kinds of radiations like alpha particle, beta particles and gamma rays or gamma radiation. Now, the question is where from does it come? As I told you, X rays are coming because of the fact that photons are scattered by electrons. That is, where do you have electrons? According to present day knowledge, you know very well that electrons stay outside the central region of the atom. When Becquerel made this discovery, the idea of nucleus was not there. Nucleus inside the atom is unknown. So, people thought the radiation that you have now, three kinds of radiations, one is positive charge, the other is negative charge, and the other one is the so called gamma radiation, which is neither positive or negative. This is some sort of radiation similar to X radiation. They should be coming from the central core of the atom. Central core, what do you have at the central core remained not clear at that time. In 1896, nobody knew about the nucleus. So, this discovery is a fantastic discovery and made us to understand what you have inside the so called nucleus of an atom. Today, we have got a nuclear bomb, we know more about nucleus. This is the first instance when people found that heavy nuclei will be giving rise to alpha particle, beta particle and gamma radiation. This is called natural radioactivity. It is called natural because it is a spontaneous emission. It is not induced, it is coming out automatically. Whenever you have got heavy nuclei, nuclei whose atomic numbers exceed 83, 83 is what? It is the atomic number of Bismuth. So, those nuclei whose nuclear charge, the number of electrons or the number of protons, they should be equal, charge should be conserved. Whenever the number of protons is exceeding 83, they are radioactive, they are naturally radioactive. So, it is called natural radioactivity. That means, spontaneously alpha particles, beta particles and gamma radiation are coming. As I told you, alpha particles are positive charge, beta particles are negative charge and gamma radiation is something like X radiation. Now, we should go still further to find what are actually alpha particles. They are positive charge. Whether protons are coming, whether they are the alpha particle, what is meant by alpha particle, what is meant by beta particle. Now, these things should be known and it took a number of years. So, you have got nucleus like uranium 238. What is 238? That is the mass number. What is mass number? It is the number of protons plus the number of neutrons. When you go to heavier nuclei, the number of protons and the number of neutrons will not be equal. To be more exact, the number of neutrons will be much higher compared to the number of protons. So, you sum up the masses of protons and the neutrons, that gives what is called the mass number. So, the number 238 refers to the mass number of the heavier atom like uranium. Now, in the nuclear reactors at Kalpakkam or Bhabha Atomic Research Center, we talk of uranium, thorium, the radioactive materials which are used for generating nuclear energy. So, this uranium 238, it spontaneously emits alpha particles which are going in this direction, the beta particles which are coming here and gamma which is coming here. You see that alpha particle is not a single particle, it has got 4, you see 4 circles, right. So, alpha particle is not a proton, it is something which is different from that of a proton. We will have a short break at this point and we will resume after the break. Welcome back at the break. As I told you, alpha particle does not contain a single particle, a proton or something, and we will now discuss about curiosity of Madame Curie. Now, Curie questioned to herself, Becquerel found the phenomenon of natural radioactivity from uranium, potassium, uranium sulfate, and they were called Becquerel rays or uranic rays, because they are coming from uranium, uranic rays. Now, she asked the question, only uranium alone in a periodic, look at a periodic table, only uranium alone has the ability or the capacity to emit this kind of radiation, wherein you got 3 different types of radiations, alpha particle, beta particles, gamma radiation coming from the center of the atom, it is coming from center of the atom. Now, this is it solely belonging to uranium? What about other elements, right? Does it come from uranium alone? Whether any other element in a periodic table will exhibit a similar radiation like what Becquerel found. Shortly after this, Marie Curie and her husband Pierre Curie isolated 2 other radioactive elements, which are polonium and radium, and the name polonium was given by Madame Curie as she was born in Poland. Even though the research work was done in France, she is a native of Poland. In order to recognize her country where she was born, the name polonium was given. The 2 radioactive elements are polonium and radium. Anyway, however, not only uranium, polonium, radium and many other elements in the periodic table, they also exhibit natural radioactivity. This is a periodic table. Bismuth is here 83, right? You got polonium here, right? 83, why did I mention 83? Any element whose atomic number is greater than 83, they are highly unstable and they are bound to emit radioactivity. So, natural radioactivity will come from heavier nuclei whose atomic number goes above 83, that of the bismuth. The bismuth is very stable, right? Bismuth, and you got polonium and here, and other elements like you got a number of elements whose the atomic numbers, mass numbers are heavier. You got americium, right? You got plutonium here, right? Neptunium, and I will talk about thorium, actinium, thorium. These are actinides. They are called the phi F elements. They are prone to give out radioactivity. The natural radioactivity will come from thorium. You got thorium series. I will be shortly talking about the neptunium series, plutonium series, americium. What is Cm? Cm is curium, named after Madame Curie, right? To honor Curie, you got curium, berkelium, californium, and what is Es? Es to give due credit to Einstein is Einsteinium, and fermium. What is Md? Md is who found the periodic table? The periodic table was formulated by the Russian scientist Mendeleev. So, the young people should know this Md stands for Mendeleevium. We talk about Nobel Prize, right? The discovery of natural radioactivity by Henry Becquerel is sorted by Henry Becquerel. It is accidental discovery, and then it was followed by Curie's, because they were curious to know whether uranium alone will exhibit this kind of radioactivity. They questioned to themselves and found there should be other elements in the periodic table which should also give rise to radiation So, the radioactivity will be coming from thorium, then neptunium, plutonium and so on, and the Nobel Prize for 1903 went to 3 people. The Nobel Prize was shared between Henry Becquerel, half of the amount was given to Henry Becquerel, the other half was divided between the wife and husband, Madame Curie and Pierre Curie. So, the Nobel Prize was instituted by Alfred Nobel. So, to in memory of Alfred Nobel, you got NO. NO stands for nobelium. The nobelium refers to the Alfred Nobel, right. Now, therefore, you will have to remember some of the names of great men who are responsible for instituting the award of Nobel Prizes, and many other people like Fermi, Einstein and Curie and so on, right. Okay. And now we pass on to find the discovery of radioactivity in other materials. Curie extracted uranium from ore, and to the surprise found that the leftover ore showed more radioactivity than pure uranium. They concluded that the ore contained other radioactive elements. This led to the discovery of elements polonium and radium, as I told. It took 4 long years of processing tons of ore to isolate enough of each element to determine their chemical properties. By chemical properties, what I mean is you should know what are alpha particle, what is beta. We do not know. Alpha is positive, whether they are protons or some other thing. Hence, we have got Madame Curie and Pierre Curie, who got they shared the Nobel Prize along with Becquerel, who says, I am one of those who think like Nobel, that humanity will draw more good than evil from the new discoveries. That is a point to be debated. Marie Curie changed the name of uranic rays or Becquerel rays to radioactivity. Henry Becquerel found radioactivity, hence initially it is called Becquerel rays or uranium rays, and the word radioactivity is coined by Madame Curie. We will talk about isotopes of hydrogen. Elements may exist as different isotopes. Example, the 3 isotopes of hydrogen are, you have got the 3 isotopes hydrogen, deuterium, and the mass numbers are different. What I would like to bring to your notice is number of protons is 1 here, 2 here and 3 here. So, and 2 means what? Deuterium is a 2 body problem. It is a proton and the neutron, right? Proton and the neutron. Here you have got hydrogen means 1 electron and that will be 1 proton, because charge should be conserved. So, 1 electron and then out of 3 there will be 1 proton and 2 neutrons. They are the so called so they differ only in the number of neutrons. You got 1 neutron here, you have got 1 proton here, you got 1 proton and 1 neutron, 1 proton and 2 neutrons. They are the isotopes of hydrogen. Unstable isotopes are so called radionuclides. Some isotopes are stable, they are stable. Some isotopes are unstable, these are unstable isotope. The unstable radioactive isotopes are given the name radionuclides. Let me, because I will be using the word radionuclides, let me tell you once again, the unstable radioactive isotopes are called radionuclides. So, the notation which is used to represent the electrons, protons and neutrons and so on. Now, that will be number of protons plus number of neutrons will give you what is called a mass number, right. Number of protons and number of neutrons, elements, lighter elements, the number of protons, the number of neutrons will be equal, that will be equal to mass number. As you proceed to heavier and heavier nucleus, you find, as I told you earlier, the number of protons will be lesser, the number of neutrons will start increasing, number of neutrons will start increasing, and if the number of protons is increasing, then what happens? The nucleus becomes unstable. Whatever be the case, nuclear force has to be understood properly, and so heavier nuclei are unstable, and in heavier nuclei the number of neutrons will be larger than the number of protons, and the ratio between the number of protons and the number of neutrons will decide whether the material will be radioactive or not. Okay? That is an important point. The sum of these two will give what is called the mass number. Number of protons should be equal to the number of electrons, that is called the atomic number, right. The charge should be conserved. E is the element symbol, right. So, you got electron here, this is the mass, and you got -1, it is negative, and proton you got a positive, neutron you got a mass number is in the superscript, charge is 0, and the charge is -1, the charge is +1 for a proton, the negative charge, the positive charge, neutron is uncharged, the mass number, neutron has got a mass and proton has got a mass, and of course, electron is having a mass which is much smaller compared to the mass of the nucleon. What is nucleon? It is a common name given to the proton and the neutron, because of obvious reasons. The protons or neutrons are to be dealt with on a common platform, because the nuclear force is charge independent. So, charge does not come into matter. So, the mass is small, and so you got almost assume 0 mass. Okay. And then you got the types of radioactivity. What I would like to tell you is you got a lot of radiation on the earth, and you got high frequency, low frequency, visible light, ultraviolet, and gamma is here. Now, we are talking about gamma radiation, that is high frequency, the penetrating power of the gamma radiation, and alpha and beta will be discussed later. And before that, we should know what are alpha particles, what are beta particles, that we will do now. Natural radioactivity is a spontaneous phenomenon. It is spontaneous, it comes out automatically from heavier nuclei, that is the important point. It is called natural radioactivity. There is something like one should ask why it is called natural, there will be something called artificial radioactivity, we will come to that later. So, the emission is spontaneous. What are alpha particles? Alpha particles are nothing but you look at this nuclear reaction, it is example for alpha particle emission. You look at uranium 238, that is the example I showed you a bit earlier. Uranium 238, it spontaneously emits what? It emits an alpha particle. What is alpha particle? You got 4 here. What is 4? 4 is the mass number. What is 2? 2 is the atomic number. You got 2 protons, right? 2 protons, and here 4 means what? The mass number is 4 means you got 2 protons, and obviously you should be having 2 neutrons, right? 2 neutrons and 2 protons, they constitute what is called alpha particle. So, alpha particle contains 2 neutrons and 2 protons. Okay. Let me go back. These are nothing but the nuclei of helium atoms. Look at the periodic table, hydrogen, helium, and so on. Hydrogen is atomic number 1, helium is atomic number 2. Atomic number is 2, but inside the nucleus at the center of the atom you got 2 protons and 2 neutrons. Therefore, alpha particle is nothing but the nucleus of the helium atom. Okay, that is important. So, the nuclei of helium atoms, they are the alpha particles. So, you should remember what you mean by alpha particle. They can penetrate the skin under small exposure, skin burn and all these things will come, and this example which I told you, and summary of the lecture goes as follows. Radioactivity is due to emission of products which arise from unstable heavy nuclei. There are three kinds of products which are emitted. Their characteristics can be understood from the nature of the deflections experienced by them due to an applied electric or magnetic field. The examples of the reactions are discussed. The questions for this lecture are: what is natural radioactivity? Mention the products coming out. Why does it occur? How are their characteristics understood? The last question being, give an example for gamma radiation. With this we come to the end of this lecture. In the lectures to come, we will see more details about beta particles and gamma radiation. Thank you.